Welcome. Let's begin our explorations here on the Unit 15 study guide so that we can be super prepared for our test on solving quadratic equations. In the first question, we are asked to solve. I see part A has two sets of parentheses multiplied together and set equal to 0. Remember, the zero product property here says that when two things are multiplied together to equal 0, that one thing might be equal to 0, or the other thing could be equal to 0. So we set each set of parentheses equal to 0 and then solve them as individual mini problems. On the left side, 2x minus 3 equals 0. You're going to have to add your 3 to both sides. So 2x is equal to 0 plus 3 is 3. Then divide both sides by my coefficient 2. X is equal to 3 halves. On the right side, my mini problem is x plus 2 equals 0. So we're going to subtract that 2 from both sides. 2 and negative 2 cancel out, leaving x behind. 0 minus 2 makes negative 2. So here's our two solutions, 3 halves and negative 2. Then in part B, I want to go ahead and solve that equation. I see it has an x squared, an x, and a constant term. That tells me that I need to get this into standard form and set it equal to 0. So that constant 18 needs to move to the other side. It's right now a positive 18, so we're going to subtract that 18, and what we do to one side, we have to do to the other side. This gives us x squared plus 3x minus 18 is equal to 0. Now I have standard form, so we're going to go ahead and try to factor this. Make that factor puzzle. Up top, a times c is going to be 1 times negative 18 for a negative 18. B is down below, that's a positive 3. So find the numbers that we multiply together to make negative 18 while also adding together to make a positive 3. And that would be then a negative 3 and a positive 6 that we can use. Use that to expand and rewrite the middle term. It's no longer a plus 3x. Now we write minus 3x and plus 6x. Remember, those can go in either order. And we bring down everything else. Go ahead now and factor, right? We completed the factor puzzle, so we group together the first two terms, find the GCF. We're pulling an x out of both of these, leaving behind an x and a negative 3. Look at my second pair, the second group in there, they have a common factor of a positive 6. Divide that out of each term, that leaves me with an x, and then negative 18 divided by 6 is a negative 3. All of this is still equal to 0. Take a look at your factoring process. Did you get the matchy-matchy parentheses? Yes, we did. That's going to be one binomial in our solution. Then the other binomial in our solution here comes from the GCFs, the x and the positive 6. Now remember, this was an equation, so I have two things set equal to 0. To solve it, I need to find out what is the x that I can plug in and make this true. So we have to split up those two sets of parentheses into the two mini problems. If x minus 3 is equal to 0, add that 3 to both sides. 0 plus 3 makes 3. And try out the other one as well. If x plus 6 is equal to 0, I need to subtract that 6 from both sides. So 0 minus 6 makes negative 6. Here we are, two solutions. X is equal to 3 and x is equal to negative 6. And then part C, we've got this x squared minus 14x plus 45 equals 0. So I see standard form with x squared, x, and a constant all set equal to 0. This is going to tell me to start thinking about factoring. So I make my factor puzzle. A times c up top, that's going to be 1 times the 45 for a positive 45. B down below, that's going to be my negative 14 coefficient. So find the numbers that multiply together to make a 45 while also adding together to make a negative 14. Again, multiplying for a positive 45, adding for a negative 14. That's going to be a negative 5 and a negative 9, because when I multiply two negatives, that gives me a positive. So I rewrite my middle term. It's no longer going to be a negative 14x. I'm going to do that as a negative 5x and a negative 9x. Bring down everything else. That x squared comes along, the plus 45 comes along, this equals 0 comes along. And so we're going to group those first two terms together. The greatest common factor here is an x. Divide it out, what's left behind, that'll be an x with a negative 5. Then you make your second two groups, negative 9x and positive 45. I see the leading term is a negative, so I know my GCF will be a negative, and the 9x and the 45 can both divide out a 9. Go ahead, do that division. Negative 9x divided by negative 9 gives us x, and positive 45 divided by negative 9 is negative 5. This is still an equation that's set equal to 0, so check out those matchy-matchy parentheses that we've got. The x minus 5 matches x minus 5. That's one binomial in my equation. The other binomial comes from the GCFs that we pulled, that x out front and that negative 9 that we had pulled in the middle. So two factors multiplied together to equal 0. This is where we're using the zero product property. So the x minus 5 piece might be equal to 0. Add that 5 to both sides. 0 plus 5 gives us 5. Or the other factor, x minus 9, can be equal to 0. I have to add 9 to both sides in order to solve, so x would be equal to then a positive 9. There's our two solutions. Then, right down below, step 2 wants us to determine the roots. I hope that you realize when you see this word roots, we are talking about x-intercepts. And I also hope that you notice and remember that the solutions we just found up above are the same as those x-intercepts that you could see on the graph. So in this question D, x squared minus 10x plus 25 equals 0, it's in standard form for us, and we're ready to factor that. So a times c up top, 1 times 25 is a positive 25. B down below, that's going to be a negative 10. Find the pair of numbers to complete the factor puzzle that will multiply to the positive 25, but also add together to make that negative 10. And that would be a negative 5 with a negative 5. I use that to rewrite my middle term. Negative 10x is now a negative 5x and a negative 5x. We bring that x squared in front, right down along. We bring that plus 25 down, bring along that equals 0. None of that changed. Now with your four terms, you're set up for some grouping. Out in front, we've got an x squared minus 5x. That has a GCF of x, leaves behind x minus 5. Then I look at my second pair, negative 5x and plus 25. If the leading term has a negative like that negative 5x, then the GCF is a negative. So it's a negative 5 that we can divide out of each of those. That leaves me with an x. And then the positive 25 divided by negative 5 makes negative 5. It's still an equation. It's still got to be equal to 0. So check it out. Matchy-matchy parentheses happening here for us. We got the x minus 5 matching the x minus 5. That's one binomial in my solution. And then a GCF of x along with a GCF of negative 5 wraps up for my next binomial. Now I do notice here that they coordinate, they match. If this was just a factoring problem, if it wasn't set equal to 0, we would rewrite this as the one binomial with the exponent 2, since they are identical. We don't have to worry about that in this case, though, because we're trying to solve. So we're going to do the x minus 5 factor set equal to 0, add that 5 to both sides, and x would be equal to 5. And our second factor, x minus 5 is equal to 0. It's a little bit of deja vu here because you're thinking add 5 to both sides and x is equal to 5. They equal the same thing. If you're thinking about that on the graph, this is going to have just one x-intercept. So you could circle just the one of them. They match. They're exactly the same. But the root, the x-intercept, only happens at one spot on the graph. The parabola horseshoe does not cross twice. So then, as we get to problem E, still thinking about roots, still trying to solve the equation to figure out where the x-intercept is, I'm looking at it in standard form, x squared x constant, and then it's equal to 0. That's my ax squared plus bx plus c equal to 0. So I set up my factor puzzle. And my a times c, 2 times negative 35 up top is going to put us with a negative 70. B down below is going to be a negative 3. So I'm trying to think about the numbers that multiply together to give me negative 70. And I mean, 70 is a big number, so there could be a lot of factors, but they also need to add together to make a negative 3. I'm going to be using a negative 10 with a positive 7 for that. So I rewrite this middle term. Negative 3x now becomes negative 10x and positive 7x. Keep everything else the same. Bring down that 2x squared. Bring down that minus 35 equal to 0. And so group our first two terms together. 2x squared negative 10x shares a common GCF of 2x, and that'll divide, leave me with an x minus 5. Then look at the second two that you have, 7x, positive 7x minus 35, that is. These can both be divided by a positive 7. And when I factor out that GCF, I'm left with an x and a negative 5 in my equation, still set equal to 0. And so I'm wondering, did I get a matchy-matchy set here? Yeah, look at that. X minus 5 lines up with x minus 5. There's one binomial for us. And then the other binomial is going to be that GCF 2x along with the GCF of plus 7. You're not done yet, though. You're trying to find the roots. You're trying to find the x-intercepts. You're trying to find the solutions. So you got to take each factor, set it equal to 0, make the mini problems. X minus 5 is equal to 0. We're going to add that 5 to both sides, and x is equal to positive 5. Or my other option, the 2x plus 7 factor is equal to 0. So I've got to subtract that 7 from both sides. So 2x equals negative 7. Divide by coefficient 2 on both of them. So x would be equal to a negative 7 halves. There we are, negative 7 halves and 5. Those are the two roots that we have to the equation in E. As we move over to example F, look at it, decide if you're in standard form. 3p squared minus 13p plus 4 equals 0. All my terms are on one side. Ax squared plus bx plus c, it's equal to 0. So we're going to try to factor. A times c up top, 3 times 4 gives us positive 12. B down below, that's a negative 13. Pick your pair of numbers. We're multiplying together to make a positive 12, but also adding together to make a negative 13. And that's going to be a negative 1 with a negative 12. Use that to rewrite. So negative 1p and negative 12p join in this problem. And we bring down the 3p squared. Bring down the plus 4 equals 0. Then go ahead and group with those four terms. My first pair shares a common factor of p. That leaves me with a 3p and a negative 1. Group together the second pair, the negative 12p and the plus 4. Leading term is a negative, so we're going to factor out a negative GCF. That'll be a negative 4 that I can divide from each of those. That leaves me negative 12 divided by negative 4 is 3, still with the p, and then that positive 4 divided by negative 4 is negative 1 for us in my equation that's equal to 0. So do you have matchy-matchy parentheses to finish the factor? Yes, I got the 3p minus 1 and the 3p minus 1 match. That'll set up my first binomial. Second binomial comes from, that's right, the GCFs, that p out in front and then that minus 4 that we pulled in the middle. Use these to set up our two mini problems. We got to do the 3p minus 1 equal to 0. So I'm going to add that 1 to both sides. 3p then equals 1. Divide both sides by the coefficient 3, so p equals 1/3. Or, got to check the other mini problem there. If the factor p minus 4 is equal to 0, add that 4 to both sides, so p is equal to 4. Here's our two solutions. Here's our two roots. Here's our two x-intercepts. They're at 1/3 and 4. Positive 1/3, positive 4. When we come down to question number 3, the directions here want us to calculate the zeros. And when you think about zeros, I need you to be thinking about the x-intercepts, which means that I need you to be thinking about the roots, which means I need you to be thinking about the solutions. They're all the same thing. It's a very, very similar process. So example G, 7a squared plus 2a equals 0. So I'm going to try to factor. My first question when factoring is always, do I have a greatest common factor? I do. Both of these terms have an a. Let's pull that out, see what's left behind. Remember, you're reversing the distributive property. So 7a squared divided by a leaves me with 7a, and then positive 2a divided by a leaves us with positive 2. This is equal to 0. So you're looking what's inside those parentheses that you have. Can I factor this? Is it a trinomial in standard form? No, it's not. What about a difference of perfect squares? No, I didn't get that either. So can't go further with that part. So we'll split it up and check out each factor. So I have a factor at the beginning, a. Set that equal to 0. Solve it. What's a going to be? It's 0. There's nothing else to do. The variable is equal to the number. And the second part, look at that. My 7a minus 2. Excuse me, that's 7a plus 2. I misspoke. 7a plus 2 is equal to 0. Solve this for a. Subtract my 2 and subtract my 2. So 7a equals negative 2. Divide by coefficient 7. Divide by coefficient 7. A equals negative 2 over 7. There you go. 2 solutions, 2 zeros. One happening at 0, one happening at negative 2 over 7. Check out problem H. Are you ready for it? I got a 6x squared plus 36x plus 30 equals 0. When I look at this, I'm asking, do I have a greatest common factor? Yes. All of these terms can be divided by 6. Pull that out. So 6x squared divided by 6 leaves me x squared. Positive 36x divided by 6 is a positive 6x. Positive 30 divided by 6 is going to be positive 5. This is all equal to 0. So I'm looking at what I have inside those brackets. That's my trinomial in standard form. A times c, 1 times 5, that's going to be a positive 5 up top, and the b down below is a positive 6. So what numbers will I use to multiply to that 5? I only have the choices of 1 and 5, and their signs have to be both positive to add the positive 6. So I expand the middle term then, a plus 1x and a plus 5x for us. Bring everything else on down. Keep that x squared, keep that plus 5, and especially keep the greatest common factor 6 that you have. Then we go ahead and we set up the groups. 4 terms in there, factor by grouping. The first 2 terms have a common factor of x, leaving behind an x plus 1. The second 2 terms in there have a common factor of positive 5, leaving behind an x plus 1. So, do you have matchy-matchy parentheses? Yes, we do. We have an x plus 1 set. That's one binomial. My other binomial will be the x plus 5 that we had from the GCFs that we pulled in there. And don't forget, you still have a greatest common factor of 6 in this equation that's set equal to 0. So all of these are equal to 0. Everybody here needs a term being set equal to 0. Every factor has a possibility. So I take the 6 and I set it equal to 0. Does 6 equal 0? Nah, that doesn't make any sense. 6 does not equal 0. So we tried it, but it doesn't work. Move on to your next possibility. What if the x plus 1 factor is equal to 0? Subtract the 1 from both sides. So x is equal to negative 1. And then I gotta try my next factor. What if the x plus 5 is equal to 0? Subtract that 5 from both sides. So 0 minus 5 gives me negative 5. There's my 2 solutions. X is a negative 1 and x is a negative 5. I'm looking at the last question on this side. 0 equals 5x squared minus 30x plus 40. All my terms are on one side. It's set equal to 0. It's in that standard form layout, ax squared plus bx plus c. So I start asking about factoring. Is there a greatest common factor? Yes, there is. I know that all of those terms can pull a 5 and divide evenly from that. So if 5 is my GCF, then that leaves behind an x squared, a negative 6x, and a positive 8. And I'm going to keep on factoring with that. Get my factor puzzle ready. A times c up top, that's 1 times 8, gives me a positive 8. B down below is going to be a negative 6. And so, what two numbers multiply together to give me 8, but also adding to a -6? That's going to be a -2 and a -4. Use that to rewrite the middle term. -6x is now a -2x and a -4x. Bring everything else on down. Don't lose that x squared. Don't lose that +8 in your equation. So I'm keeping it rolling right along. Got my 5 GCF coming with the ride, but we're going to go ahead and make those groups. So the x squared and the -2x shares a common factor of x. Pull that out, leaves me with x minus 2. Then my next group, -4x and +8. If the leading term is negative, the GCF is negative, so I can divide a -4 from each of those. -4x divided by -4 makes +1x, and then the +8 divided by the -4 makes it -2. So do you have matchy-matchy parentheses there? Yes, we do. X minus 2 and x minus 2 line up to be a binomial in this problem. The next binomial is the GCF that we pulled x with the GCF that we pulled -4. And don't forget, at the beginning of the problem, we pulled that GCF of 5. So this all is multiplied together and equal to 0 in my equation. So anything that's multiplied together to equal 0 gets a term being set equal to 0. So maybe the 5 equals 0. Wait a minute. 5 doesn't equal 0. That doesn't make sense. But we still had to give it a try. Then I go for the next one. What if the x minus 2 factor is equal to 0? Add that 2 to both sides. So x would then be equal to +2. And lastly, I'm going to check out if the x minus 4 factor is equal to 0. Add that 4 to both sides. So x equals 4. So here's the two answers that I got that make sense because 5 doesn't equal 0. So my two zeros are at 2 and 4, which means that my two roots are at 2 and 4, and my two x-intercepts are at 2 and 4. So if we go ahead and flip on over to the back, question 2 wants us to write down the factors and the zeros for this graph. So to find the zeros, we are then looking at where the graph crosses the x-axis. Identify those locations. The graph crosses at -5, and the graph crosses the x-axis at -3. Those are my two zeros, which means that they're also the two roots. They're also the two x-intercepts. So when I go to find the factors, did you notice the pattern and the connection that we had on the other side? Let's take a look at some of those. In part C, x minus 5 ended up with a solution at 5. X minus 9 ended up with a solution at 9. Curious? And how about then in part H? We had the x plus 1 that ended up with a 0 at x minus 1, -1. And when we had the x plus 5, the solution ended up at x equals -5. So the values are staying the same in there, but the signs are, yeah, that's right, the signs are coming out opposites. Check it again in example I. We had x minus 2 as the factor, but the 0, the root, was at +2. We had x minus 4 as the factor, but the root, the 0, was at +4. So we need to apply that same rule now here in the number 2. We know the 0 is happening at -5. So I'm going to have to turn that into a factor, a binomial of x with the opposite sign, +5. Then we knew about this 0, this x-intercept at -3. So its factor uses the opposite sign. Instead of -3, it's got to be a +3. Remember, if you put these two factors multiplied together into your Desmos calculator, it should create the graph that we just had here. So you can check your answer in that fashion. Now, number 3 wants us to use the quadratic formula. So let's go ahead and make sure that we have that written down. Yes, the quadratic formula is on the formula sheet, or it will be written on the board or the test for you. So quadratic formula, -b plus or minus the square root of b squared minus 4ac, all divided by 2a. So you do not need to have that memorized, but you do need to be able to use it. So when I look at part A there, and I'm going to identify all of my pieces because it's got to be in standard form. I need everything on one side of the equation and set equal to 0 so that I can identify in here A is my first coefficient 2, B is the next coefficient, that's positive 8, C is the constant all on its own, that's negative 24. We use these and we start plugging in. Sometimes I like to make a template, negative B plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. And so I do this sometimes, and I leave all of those blanks with parentheses, because we already know that every time you take a variable out, you put parentheses in its place. I do this to make sure that I don't mess up any of the signs. And so then I start filling them. Negative b at the beginning, so b gets the 8. B squared inside that radical, b gets the 8. The negative 4 times a times c, that's going to be times 2 and times negative 24. And then my denominator is 2a, so that's going to be times 2. So we go ahead and start cleaning this up, simplifying. Negative 8 is simply a negative 8. Plus or minus the square root of, well, I know that 8 squared is 64. And then we're going to do the negative 4 times the 2 times the negative 24. That gives me positive 192. This is all divided by, and then simplify that denominator as well. 2 times 2 is 4. So let's keep going underneath of the radical. Negative 8 plus or minus the square root of, what is 64 plus 192? That's going to be 256. This is all divided by 4. Well, I know 256 is a perfect square. So what is the square root of 256? That's going to be 16. So this fraction, negative 8 plus or minus 16, is divided by 4. So now we're going to do this with the arithmetic to finish it out in the two cases, right? Negative 8 plus 16 is 8 divided by 4. That's going to tell me that x is equal to 2. Or, other case, the negative 8 minus the 16 is divided by 2. Because remember, it's plus or minus, so you got to try them both. Got to work them both. So the negative 8 minus 16 in this case would be negative 24 divided by 4. So that's going to tell me that x is negative 6. There's our two solutions with the quadratic formula. Let's go through this again here with example B. I got it in standard form. I see everything's on one side. It's equal to 0. Identify that A, B, and C. A is an invisible coefficient 1. B is a positive 4. And C is a positive 3. We're going to use those to plug on into our formula. So x is equal to a negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And so we fill in these values. That b value is a 4, b value is a 4, a value is a 1, c value is 3, and then the a value is a 1 for me to plug in. So I've got a negative 4 there. Simplifies nicely. Plus or minus the square root of, let's see, 4 squared is going to put me at 16. And then negative 4 times 1 times 3. So that's going to be a negative 12. And this is all divided by, now my denominator is 2 times 1. That's 2. So keep on cleaning up here. Negative 4 plus or minus the square root of 4 from that 16 minus 12 divided by 2. I happen to know that 4 is a perfect square. So convert that, negative 4 now plus or minus 2 divided by 2. So with that plus or minus sign, I got two solutions, two sets of arithmetic. The negative 4 plus the 2 gets divided by 2. Negative 4 plus 2 is negative 2 divided by 2. That's going to make negative 1. Second case is going to be the negative 4 minus 2 divided by 2. Negative 4 minus 2 in the numerator is negative 6. Divide by 2 would give me negative 3. So I've got a solution of negative 1 and a solution of negative 3 there. On to problem C. 4x squared minus 6x minus 2. And so for that, I got to plug these things in to the quadratic formula, which means I got to know my A, my B, and my C. A in this case is 4, B is the -6, and C is the -2. Because everything was on one side, it was equal to 0. Easy to pull those values and get them ready. So to solve for x, we're using the quadratic formula -b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. And then I start filling in those values. B gets the -6, B gets the -6, A spot gets the 4, C spot gets the -2, and the denominator, my A spot, gets the 4. Fill these in, and we're going to simplify. So out in front, we got a -6. Clean that up. It's a +6. Keep the plus or minus sign into the square root. Now the -6 squared, that's going to be +36. Then I got -4 times 4, which is -16. So -16 times -2 is +32. This is all divided by, now 2 times 4 there is 8. So we're going to clean up, simplify the radicand a little bit more. 36 plus 32 is 68. That's divided by 8. Now, square root of 68, that's not a perfect square. But I'm going to check out what we can do with this square root of 68. Can I write it in simplest radical form? Let's see. What is 68? Let's see. That could be divided by 4 times 17. 17 is a prime. And 4 can be 2 times 2. So any pair of numbers with a match gets written once. Numbers without a date stay inside the radical. So now I'm talking about 6 plus or minus 2 square root of 17 over 8. And at this point, we're going to check out those 3 values. The 6 out front, the coefficient on my radical, and the denominator. Do these 3 values have a common factor? We're going to divide them all by the greatest common factor if we can in order to simplify this problem. And we see that all of these values are even. They can all be divided by 2. So that's what we do to get to our final answer. So I take that 6 divided by 2, it's 3. Plus or minus 2 divided by 2, that's 1. So square root of 17 with that 1 coefficient divided by then my 8 divided by 2, which is 4. So we are talking about my solution as 3 plus or minus the square root of 17 divided by 4. And you can leave your answer just like that. Certainly, if you are checking this problem in the graphing calculator, you are typing that original equation in. Then your next line of display, type in the 3 plus square root of 17 over 4. Check out that decimal. Find out if it matches the decimal with the x-intercept on your graph. Then you do another new line, type 3 minus square root of 17 divided by 4. See if that decimal matches the other x-intercept on your graphing calculator. Part D then wants us to also solve with the quadratic formula. This one isn't ready to go. Notice that it's not in standard form. So I need to add 12 to both sides in order to get it equal to 0. So x squared plus 10x plus 12 is equal to 0. And I'm going to use this to identify A is my coefficient 1, B is the coefficient positive 10, C is that constant positive 12. I use these to plug into my formula. Negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. And so I fill in these values. My b is a 10, my b is a 10, a is a 1, c is a 12, and a is a 1. So we gotta simplify this stuff. So I've got negative 10 out in front, plus or minus the square root of. Now 10 squared there puts me at 100. Now I've got negative 4 times 1, that's negative 4, times 12 is negative 48. This is all divided by 2 times 1 is 2. go ahead and do that subtraction under the radical. So negative 10 plus or minus the square root of 100 minus 48 is 52. This is all divided by 2. So that 52 is also not a perfect square, but I can take that square root of 52 and I can try to simplify the radical. So let's see, what can I do? 52 is even. I can divide that by 2 and I'd get 26. So 2 is a prime. Now 26 is also even, so I can divide that by 2 and I'd get 13. 2 is a prime, 13 is a prime. So I'm going to rewrite, instead of the square root of 52, I'm going to put in that 2, because I had a match, once right at once outside, and then times the square root of 13 for my primes that are left alone without a match. So you're seeing it. X is equal to negative 10 plus or minus 2 square roots of 13 over 2. And again, we're going to look at those 3 values, that negative 10, that 2, and that 2. Do I have a greatest common factor that I can divide out of these? Yes, all of these terms, all of those values have a common factor of 2. So I can divide that out from each of them. So the negative 10 divided by 2 is negative 5. Keep the plus or minus. Then 2 divided by 2 is just a 1. So I don't have to write that as an invisible coefficient. Keep my square root of 13. And the denominator, 2 divided by 2 is 1. Again, realize I don't have to write an invisible 1 denominator, so you can just have negative 5 plus or minus the square root of 13 as your solution. Again, you can type the original equation into your Desmos calculator. You can type negative 5 plus the square root of 13 into your Desmos calculator. See if this decimal matches the decimal that you have as an x-intercept on that graph. And then try the other option, negative 5 minus square root of 13. Does that decimal match the decimal that you get from your x-intercept on the graph? I hope that you feel so much more confident now about solving quadratic equations. Best of luck on your test.